since I don't have softball this evening. It's the plan. Okay. Let's finish up the one section of chapter 15 that we're learning about, which are the lecture 10 slides. And what I want to talk about is how we predict when, what is this PPT abbreviation stand for? Precipitation. Okay. When or will the precipitation happen? Basically, what I'm asking is what? If I want to know if I will see precipitation, I'm essentially asking, is the solution saturated or unsaturated, right? Because if it's saturated, if the concentrations of the ions are enough that we have reached the solubility of the compound, then it's saturated. If the concentrations are too small of these ions, if the concentrations are too small, then what? It's not at equilibrium. Will we see a precipitate? No, we only see a precipitate. We only see solid when it's what? Equilibrium, when that means when it's saturated, right? Because saturated and equilibrium for these compounds are synonymous. Okay, saturated means it's at equilibrium. Okay. Supersaturated is a special, you have to physically increase the temperature, right? And then you have to allow the temperature to cool back down, right? So that's not even equal, that's not an equilibrium either. It's like it's not at equilibrium, and if you disturb it, then it's going to go to equilibrium, and that's why you see like the sugar crash out in the sugar solution. That's because it wants to get back to the just regular old saturated state. Okay, so what we want to compare are ion concentrations, okay? And we can do that at any point in time using what expression? Which is the symbol for at any point, not just equilibrium, but at any point. Q, right? Let's compare the concentrations. Let's do a calculation with the amounts at any point. I don't know if I'm at equilibrium yet. That's kind of what this question is asking, right? When a question says, will a precipitate form? It's really asking you, is this solution at equilibrium?
So K is only at equilibrium.
Only. Q is at any time. With any amounts, whether you know it's at equilibrium or not. So, because in this chapter we're talking about solubility products, right? I'm going to put the SP after my Q value, but you guys know how we calculate Q. It's the exact same products over reactants as we calculate K. Okay. We're going to compare. Compare Q to K. What we have to what we know it should be at equilibrium. You guys should be able to tell me this. If Q, SP, is bigger than K, SP, will we see precipitation occur? That's what this question is asking. You can try to think about shifts, which is still valid. If Q is bigger than K, that means the reaction is heavy on which side? Other way. Harsh side. You can think about it, but here's what I'm wanting to know. If these are the concentrations when we know we're saturated, and I'm telling you that these concentrations from our calculating Q are even bigger than that, guys, will we see precipitation happen here? Yes. 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 We will see precipitation. We will see solid. And what if Q is less? We will not see any solid because the solution is what? Unsaturated. Unsaturated. You don't have enough ions to make the solid form yet. What if Q is equal to K? That means that we are at the saturation point, right? That's what that means. If Q is equal to K, that means we're right there at the limit. Okay. I don't think you should see that, right? But it's pretty much going to be, is it bigger or smaller, are the cases you will be asked to judge. Is it bigger or smaller? But we'll just write, if Q equals K, then you are just at the saturation point. Okay. Look at number 11 on our in-class examples. Let's try some prediction. Let's predict. Will CHEM141200, what's the name of that? Close. Calcium hydrogen phosphate. That ion is, okay, so there's our calcium ion, right? This is one polyatomic ion, okay? It's not multiple ions, it's one ion. And it's called the HPO4 2- ion. Hydrogen phosphate is the name of that ion, hydrogen phosphate, okay? Will this compound precipitate? Here's its KSP value. I think, what did I write? 7 times 10 to the negative 7. Okay. Just knowing the value of KSP is not enough to know, will it precipitate? Because what is KSP dependent on? It's concentration dependent. All of this is concentration dependent. What concentrations am I told that I have? I have 0.00030 zeros in front of it. 3 zeros in front of the calcium, and then 2 in front of the hydrogen phosphate ion. Ugh, okay, I know. No. This is easy to mix that up for sure. Okay. So what do? I calculate Q, but I need to know, right? What is my dissolution equation for this compound? How many of each ion do I have when it splits? I should have one of each, right? Because these are in a 1-to-1 ratio. Okay. Why do I need to know how many ions I have? That will absolutely influence. It's you have to have it in your K and Q expression as the exponents. That's what I'm trying to say. Very inelegantly, I'm trying to say that. Okay. So when I calculate Q of this sparingly soluble compound, I am just taking the concentration of calcium ions times the concentration of hydrogen phosphate ions. So 0.0001 times 0.001. So that's 1 times 10 to the negative 7th, I believe. So what is the comparison now between my Q and my K value? My Q is less than the K for this solid. And what does that mean? Will I see precipitation? I will not. I mix these together, I'm not going to see any solid. In order to see solid, I would have to do what? Increase one of those. Both of them increase, right? So no precipitation would be observed here. Look at 12. Look at 12. This number 12 has something in it, a kind of, it's not a trick. It should be common sense, but you know, this is chemistry class. So we don't always recognize when common sense should be used. Okay, here we go, this one. Will silver chloride precipitate? Okay, will precipitation happen? So we know that to solve this problem, we have to compare Q to K. Okay. In order to calculate Q, I need the concentrations of each ion. Here's why this particular problem is tricky. Guys, I promise you, you will have something like this in your homework and on the test. What is tricky about this problem is, okay, I'm given a concentration of this compound, and I'm given a concentration of this compound, okay? But then what am I doing with these two compounds? I'm mixing them together in equal volumes. I want you to think about what that means, okay? I want you to think about this. Ready?
Would that mean that it'll be 1 over?
You are very much on the right track, I think. What's the compound? What's the first compound I have? Silver nitrate. Silver chloride is what I'm going to try to solve Q for. Okay. I'm told that I have silver nitrate, a solution of silver nitrate. Is this my solid? Is this the compound that does not want to dissolve? No. Silver nitrate is very soluble in water. How do we know that? Because it has a nitrate ion in it. Plus, it's already described as being in solution. Okay, that's a pretty big hint that it's dissolved. Okay. So what does this split into? Silver ions and nitrate ions? So what? This is not the equilibrium yet. This is not the equilibrium yet. This is silver nitrate as it's dissolved in water, right? What is the concentration I'm told I have of the silver nitrate? 2 times 10 to the -4th. Okay. We looked at this a little bit yesterday. If this is 2 times 10 to the -4th, then what's the concentration of just the silver ions when it dissolves in water? Isn't it the same? Because this is a 1-to-1 compound ion ratio. Okay. What about our other compound? I'm trying to make silver chloride. Here's my silver, and we don't need that NO3 at all. I need this silver concentration. What's the other thing I need? I need a chloride ion concentration. Where's my chloride ions going to come from in this problem? Good. So I have sodium chloride, which is soluble or insoluble? So soluble. Okay. Yes. Very soluble. Again, so when this, there's the one I want. Get rid of these. Boom. Okay. Sodium ions. Do I care how many sodium ions there are? Nope, just the chloride. Okay. And how many chlorides do I have? So this was 2 times 10 to the -4th molar. So my chloride is 2 times 10 to the -4th molar. Okay. So when it says I mix equal volumes, okay, equal volumes. I didn't give you an exact number. Pick a real easy volume. 1 liter. 1 liter. Okay. Let's pretend 1 liter. Let's say I have 1 liter of silver ions and I have 1 liter of chloride ions. Okay. And I mix them together. You guys. What is my new total volume? This is not these two, so nothing's going to happen. Don't think something's going to happen. I'm just illustrating a point. If I have equal volumes and I mix them together, what have I done to the concentration of both of those ions? Did I double them? I have them. I diluted them. What is my new total volume? Let's pretend. What's my new total volume? 2 liters? 2 liters total now, right? What's that new concentration now that I diluted it? This particular example, it is half. But how do we solve any dilution? What's the equation that we use? Solve for the new diluted concentrations using M1 V1 equals M2 V2. You got to do that for both silver and for chlorine. You got to do it for both. Silver, what was the concentration we started with? 2 times 10 to the -4th. We made up a number here. If you were given a number, you would use that volume. We said, let's pretend we have 1. Okay, 1. What's my new combined volume? Here, we're saying it's going to be 2 liters, right? But if you have real numbers, what do? You just add those two numbers together, right? That's what we did, 1 plus 1. What's the new concentration? Okay, solve for M2. Solve for M2. So my silver ion, now that it is diluted, is 1.0 times 10 to the And my new chloride ion concentration diluted is also 1 times 10 to the negative 4th. Now that I have the actual molarities, once these two are mixed together, now you can do what? Solve for QSP. Now you can do that. So am I solving for QSP for this reaction right here? I'm solving it for this reaction, right? What am I solving it for? QSP, KSP is only for sparingly soluble compounds, right? That's my silver chloride that I'm discussing in this problem. That's this compound. I'm talking about making this compound from these two, but this is the thing I'm trying to see if it's going to precipitate. It's this guy. Now this is an equilibrium, right? Remember, in what this problem described, where we were adding volumes, therefore we diluted those concentrations, right? Be sure you are using which concentration in your Q? The one you calculated, that's the one. The diluted one is the one that goes into your Q expression. The diluted one is the one that you use, not that original value. Over here, at number 11, if you're just told this is the concentration, well, then that's what you use. This would be like after I've already mixed them together. Here's the numbers, right? That's why we used those numbers. This described the process of dilution. That's why we had to calculate that. The dilution process is described to you. You have to calculate it. So what is Q? 1 times 10 to the negative 8. Very good. And how does that compare to the KSP value of 1 times 10, 1.6 times 10 to the negative 7th? 10th. Woo, not okay. How is Q compared to K? A lot larger, actually. About 100 times larger. Yeah. So will we see silver chloride precipitate from this mixture? Yes. Yes. Okay. Well, for these kinds of equilibriums in our Ks, we're not dividing either, are we? Because that's a solid. Okay. What goes into the Q expression is the same rules as what you would write for K, meaning no solids and no. Very good. If I had, Caitlin, if I had coefficients here, would I still need to make those be exponents in the Q, just like I do in K? Yes, absolutely. Okay. In fact, I may have one we can look at. Okay. So we talked, will precipitation happen? Compare Q to K. What about at what concentration of an ion do I see precipitation? Yesterday, we practiced calculating just straight solubility, right? The S from our ice table, or X value from our ice table. Today, I'm talking about, well, what is the actual constant equilibrium concentration that's needed for an ion? Sometimes, is that the same as the S value? Yes, sometimes. Sometimes. Is it sometimes 2S or 3S or something else? Sometimes. So that's what we're going to figure out now. What is the actual concentration of an ion that I need to see precipitation? That's what we're doing. We're going to calculate an ion concentration needed in order to see precipitation. So you're going to be told, one of your ion concentrations. Okay. You're going to be told that in the problem. Here's the concentration of one thing. Here's the not the concentration. Here's your K value. Here's your K value. Solve for the one you don't know, right? That's what we're doing here. We're solving for the one we don't know. Look at number 13. Okay. A solution contains 0.0020 moles of, what's that ion? It's the one we worked with in the lab yesterday. It's the yellow one. It gives you the cancer. It's the chromate ion, the fun one. Yeah. It's the chromate ion, CrO42-, chromate. 0.002, God bless you, moles per liter. What is that? Moles per liter. That's your molarity. That's your concentration, right? What solid is it that I'm trying to look at? What is the thing I'm interested in if it's going to precipitate? Which compound am I interested in if it's going to precipitate? Which silver one? I am interested in this silver chromate. The silver nitrate is added to this solution in order to form the silver chromate. Okay. Look, how do you know that? Which silver compound did I give you the KSP value for? That's the one that you write the equilibrium for. Okay. Ding, ding, ding. Okay. So I am interested in this equilibrium for this sparingly soluble salt, silver chromate. How many silver ions does this compound contain? Oof. Plus 1, 2 of them. There we go. And we got 1 chromate ion. And so my K expression would look like what? Concentration of silver to the second power times the concentration of the chromate. And this is equal to, what is our K value? 9.0 times 10 to the negative 12. Okay, so if I want to solve for silver, that means I had to be told the chromate, which I was, wasn't I? What is the concentration of the chromate ion that I have? 0.0020 capital M, moles per liter. we're going to divide by this and then take the square root. Yeah. Yes, you may do that as well. In fact, that's actually kind of what I tend to do, is do it by 1/2 exponent, but there's 1/2, same thing. Excuse me. 6.5, sorry, excuse me. 6.7 times 10 to the negative 5. Molar, because this is a concentration. So that means at less silver added than this, am I going to see any precipitation? No. At this point is when I will begin to see precipitation happen, at this concentration. And then one last thing, and then we'll be done with chapter 15, I think. We are going to start a new chapter today. So when we finish this, we're going to take a break, and you can go and anything. And then I have new chapter 14 stuff up here. So yeah, I know. What y'all want me to do? Petition to go back to a 16-week semester? Yes. Yes. Okay. No. Although I will say today I do need to absolutely leave. Like I got to be walking out the door of the building to my car by 2:20. Like I got to go because I got to go to Longview and get my mom and then come back here to Kilgore by 3 o'clock to meet the realtor. So we got to. So yeah, we got to get going. Okay. Yeah, now I lost my train of thought. Okay, here we go. This is the slide I wanted to look at. Okay, so what if, here we go. Here's what the last kind of application of K values that I want to share with you guys. Okay. All right. If we are looking at we're looking at 2 compounds. Okay. And they are somewhat similar to each other. Okay. And I'm going to explain the 2 criteria when I say similar. Can you predict which one of the compounds would precipitate out of a mixture first? This is the question I am posing to you guys. If you have 2 compounds that you can make from a mixture, I have 2 compounds I can make from a mixture. Let's pretend. Here's the question. Can you predict solubility just looking at K values? This is my question, okay? So we got a mixture of 2 ions. Could we have more than 2 ions? Yeah, let's keep it simple. Let's just say 2. Okay, just talk about 2. Let's say I've got chloride ions and I've got bromide ions. Okay. And I add silver ions to my mixture. What's in my test tube? Both chloride and bromide at the same time. Let's pretend right here. Okay. Both chloride and bromide at the same time are in the same tube. And I'm going to go get some silver and I'm going to come drop it in. Are we going to see any insoluble compound? Yeah. What are the two possible compounds that we can see formed? Silver chloride and silver bromide. Okay. So those two compounds look like this, right? Yes. And this. But which one is actually going to begin to precipitate first? The question I'm asking is, can I predict that by just looking at the KSP values? If I gave you the KSP values, could you tell me, could you predict which one would drop out first? The answer is yes, if. Yes, if you got to have those ions at the same initial concentrations. You can't try to predict if there's 1 molar chloride ions and 0.001 bromide. That's too uneven. You can't use this comparison if they're so uneven to each other. If they're the same, yeah, we can do this comparison. Also, say what? If they're, let's say they're both 1. Yeah, you can use K values. And they got the two compounds have to have the same ratio of cation to anion. 1 to 1. 1 to 1. Maybe they're both 1 to 2. Maybe they're both 2 to 3. They gotta be the same. Both compounds you're comparing have to be the same ratio. Cation to anion. If those two criteria are met, then yes, let's look at the K values. Okay. And I think I've decided that that's the only scenario I'm going to give you guys or ask you about. I think I've decided that's the only scenario I'm going to ask you about. If these weren't true, you didn't have the same concentrations, you would have to do the math for each one. You'd have to calculate Q for this compound and compare it to K. And then you'd have to calculate Q for this compound and compare it to its K. And then tell me which one's going to precipitate out first. So let's see, what is the relationship now? What is going to be the relationship? So if I tell you that the KSP for silver chloride was 1.6 times 10 to the negative 10th, okay, we saw that earlier. And I tell you that for silver bromide, the KSP is 5.0 times 10 to the negative 13. Which one precipitates out first? What's your instincts tell you? The smaller KSP requires smaller concentrations, therefore it will precipitate first. What's another way I can phrase, instead of saying it precipitates first, another way I could phrase this is I could say that the smaller K value, this compound has the lower solubility, right? It's the least soluble of the two options. Okay, you understand what I'm saying? Therefore, what is the answer to my little example here? Which compound is going to precipitate out of this mixture first? Silver bromide. Solid silver bromide in this example will come out first. Yes. Good job. And how did you get that? What did you do to recognize that? Smaller K value. And how do you know that you could just look at the K values? What are the two things that have to be factual? The ratio of the ratio's got to be the same for all the compounds. 1 to 1, 1 to 2, got to be the same. And if you're told, you may not even be told about the concentrations. Okay, if you're not, then you don't have to worry about that. If you're given concentrations, they got to be the same initial to compare. If they're not the same, then you got to do math. You got to calculate Q and compare to K, like we just learned earlier. One last example, 14, which is this concept right here. And 14 actually has two parts to it. I just want to do the first part. So we're just going to look at the part of 14 that says which insoluble compound is going to precipitate first. The second question I asked about at what concentration, I mean, we could do that, but I just don't feel like it. We need to move on. So at which concentration? That was something we just practiced on number 13, right? At what ion concentration will precipitation happen? That's the second part of this question. I just want to focus on applying this. Which insoluble chromate compound will precipitate first? Yes, but I may not ask them together in the same question. Yeah, I know, right? Yeah. I likely will not do that together in the same question. Okay. But absolutely, can I ask you at what concentration will something start to precipitate? Yes. But that was that, like that, yeah, that was algebraically solved for that. Solve for the one you don't know. Mm-hmm.
How would we solve for the maximum concentration?
It's that means yes, that means at equilibrium. The maximum in this chapter, in this context, the maximum concentration is what it is at equilibrium. Yes. Yeah. Okay. Barium and strontium can make compounds with chromate. So if I've got a solution, now this is actually the example I have here. If I've got a solution that has what concentration of barium? Okay, 0.1. And it's also, okay, so the initial amounts are the same. The two compounds, barium chromate and strontium chromate, do they have the same ratio of cation to anion? 1 to 1. 1 cation to 1 anion. Yes. So can I just look at the K values here? Yes. Look at the two K values. How do you predict which one is going to precipitate out first? The one with the smaller K value. Let's see. Where did I put this? I don't know how much of a difference I'll really be able to tell, but oh, that has stuff in it. Okay, so this has barium and strontium, same concentrations. I'm gonna put some, this is not concentrated. This is the one that we were using in lab, chromate ion, but let's just see if we can see anything. Ooh. See that? Our two options, barium chromate or the strontium chromate. Which one is precipitating out first? Should be the barium chromate because it has the smaller what? It has the smaller KSP value. KSP for barium chromate is smaller, so barium chromate is coming out first. If I keep adding more chromate ion, will I eventually start to precipitate the strontium one? Yes. That was what the second part of this question is, right? Okay. Tell me concentrations when the other one will begin to precipitate. I have that solution on the very next slide. If you were so inclined to practice calculating a concentration, you can certainly come back and look at this second part of this number 14. Okay, and then I want to skip, guys. I already said I'm only going to ask you to do comparisons when you can compare. So you can skip number 15. Okay. Again, how would you solve for that? You just do the math and compare Q to K, but I'm just don't have to worry about that. Yeah, we don't want to do that. And then yesterday we talked about the common ion, right? And so that was the end. Okay. Break. So I made this set due Friday night. Chapter 15, set 1 is due Friday night. It's up. And like I said, our test over 13 and 15.1 will be Monday, and there will be an active chem quiz that I will get ready for you guys probably by tomorrow, and it'll be open over the weekend for you to take just one quiz. Okay. On the test or on the quiz? Oh, I don't know. Hang on.